All right, we're taking a look at the data importing coding challenge, and we're going to do this with base R. So I'm recording this right now. You might have seen another video where I started doing this in the tidyverse approach, but had computer problems, which is a totally normal thing to have here. So to avoid those computer problems, I'm going to go to base R, which often makes things simpler. This means the code that I will figure out right now should be code that will work nicely on Replit, even if you don't have an upgraded account that gives you more computation power. So I am going to come back to Rstudio. I'm going to clear out my workspace. I'm going to not install tidyverse. Actually, you know what I'm going to do? I'm going to save this as main_base_r.r. Get rid of that. And so what I've got at this point is I clear everything out, I load in the population data, and I load in the population flow data. Now I'm going to use the by function, and in order to make sense of that, I'm looking at the help function, the help page for by. By, we're going to apply a function to a data frame split by factors. Now there is a data type in R called a factor, which is when you have sort of categories. So let's say you're looking at, let's say you're working for McDonald's and you're looking at revenue data. Some of these are going to be at normal locations. Some are going to be, say, rest stops along the freeway. Some are going to be in airports. So you might have categories like airport or rest stop for places where you've got sort of more of a, captive audience. Versus regular locations where you're more open to competition. Right? So you might have factors in your data set to categorize like that. In this case, our factors are going to be counties. We're going to be organizing different counties. We're going to be organizing our data by county and state. So we're looking at data that is population of different counties within different states, and then flows is looking at people's movement between those counties. So we're going to treat county A as our baseline, and people will move from A to B or from B to A, and we're going to be looking at that data. Now, we aren't really doing some sort of like a demographic study. There's no one who's going to make sure, there's no one counting on us doing everything the right way. This project isn't about getting the right answer, it's about getting comfortable with the tools. So if we kind of cut some corners, get a little bit sloppy some places, it's not the end of the world. More important is that we get something out of it that's going to make it so that when we are doing something where we have to be accurate, we're not stumbling over the tools, and we can focus on the problem itself. So we've got our data in. Now we're going to combine our data. Now we don't have inner join. We're just going to use merge. That's our base R way to do this. So we do that. It's going to take a little while because this is a pretty big data frame. Now, something else I wanted to show you before I close help is I'm looking at this for by, and what's saying is this is a function that is a wrapper for tapply. So a wrapper means that we've basically made a different way to write code for the same underlying code. So we're going to use by, but really we're using tapply in the background, which allows us to apply a function over a ragged array. Apply a function to each cell of a ragged array, that is to each non-empty group of values or data rows given by a unique combination of the levels of certain factors. Right, it doesn't sound like it means very much at this point. But what this means is we're going to do things like, let's find the mean for our in-migration rate by county, right? And if we've got a row where there isn't any migration into a particular county, then we ignore that county entirely. So let's go ahead and do this. And I am a bit rusty here, so you're going to watch me struggle with this. You're going to see me make some mistakes, and hopefully that is also instructive. So we've merged our data. We've got this thing called DF. We've got pop. We've got flows, and that is all we've got at this point. DF is a little smaller than flows, so there were some rows in flows that we have thrown away when we merged it with pop. I am curious, but I'm not going to figure out which rows are exactly missing. It's close enough. It's good enough for the purposes of this particular assignment. But in a real-world setting, if you see something like this, a difference in the number of rows, you want to see, well, why are some rows missing? And hopefully it's just that those are rows that don't have data, right? So some really small county somewhere where there's like 30 people living in one particular county in Alaska, maybe nobody moved in or out in the year 2020, and so they just don't show up when we merge that with population. I'm not going to find out right now. So we've merged our data. Now what we need to do is create these new columns where we're going to convert our raw numbers, say 44 people moved from county A to county B, and translate that into some percentage of people from county A moved to county B. So the simple way to do that in base R is we're going to say df $, and that allows us to access a new column. So for example, if we say DA $ state A FIPS, and we just run this on the console, we get a whole bunch of nothing, right? A whole bunch of raw data, 420,000 entities that aren't being printed, and the first 1,000, the value is just 1, right? So this is just that column all there. We're going to name a new column, so let's call it in percentage, and we will say that this is going to get the value of df $B to A flow. That's the number of people who moved from county B into county A, and we're going to divide that by df population 2020, which is the population of county A. Cool. We're going to copy this line. This is going to become out. This will become total. And actually, you know what? Let's make this net. So our out is going to be A to B flow. Our total is going to be, let's just scroll through this. I think we've got a gross, A and B gross flow we'll use for that. And then for our net flow, we will use, we've got B to A net flow, A to B flow, we've got an A to B net. We've got a B to A net. All right, we don't have an A to B net. So what this means is we're only the data we've got calculates it in one direction. So if we're in County A, Suffolk County, New York, how many people move from Nassau? How many people move from Suffolk to Nassau? And if we have a positive number, that means more people are moving east than west. That's what this figure would show if County A is Suffolk and County B is Nassau. It's helpful to just kind of walk that through in your head just to make sure it's clear and you're not misinterpreting this. It's really easy in a case like this to think that you've actually figured A to B net flow. But again, like I said, we're not going to sweat getting this exactly right. We're just worried about getting the tools right. So what we've done with these 4 rows of code is we've created 4 new variables, or we will have once we run it. So let's go ahead and run these. No errors, that's good. And if we look at the head of DF, the first 6 rows, we can see something about what we've got, and we've got in percent, out percent, total percent, which should match in plus out. 0 plus 7, it's giving us 7. 0 plus 8, it's giving us 8. That's good. We got 0006 and 00007, and we get something. All right, this looks good enough for our purposes. So we have calculate flows as percentage, And strictly speaking, this isn't actually a percentage, this is a ratio. If we multiply these by 100, we would get a percent. But it's the same information, just a slightly different format. All right, so we've got that, which if we were doing in tidyverse, we could just do as a set of mutate calls, but no problem. This wasn't that much harder to do in base R. Now to get the summary stats, that's where things are going to get a little bit messier. So in tidyverse, we just pipe through, we group by, and then we summarize and we do a bunch of stuff and we get everything we want. I'm going to comment that out for now, and I'm going to do this using the by functionality. Let me just pull the help up so that I've got it in front of me, and I'm going to scroll down to an example just so that this fits into my head a little bit better. So we want to take df. That's our data that we're using. The indices, these are the factors. So in this case, let's go to view df. So state AFIPS, county AFIPS, that's an easy column to work with, but I'm going to use the names just because it'll be a little bit easier for R to identify that those are categories. It's not going to accidentally treat it like a number and try and add up 1 and 1. What happens when you add Alabama to Alabama? It's not a meaningful question. So we're going to make our indices the names, just to be careful. It should work if we use the FIPS codes, these numeric representations, but we'll do the names. So we will do df square brackets. So there are different ways to get into stuff. Let's just look at that while we're here. So df dollar state AFIPS, I'm going to pipe that into head, gives us that column. And then here we're just saying give us the first 6 values of that. If we were to say df dollar sign, let's say 1, 1, this will give us the first row and the first column, which should be 1. If we say 1 to 3, it's going to be the first row and the first 3 columns, so we get 1, 1, Alabama. That's good. If we said rows 1 to 3 and columns 1 to 3, then we'll get those first 3 rows, those first 3 columns. So what we're seeing here in the help, and actually let me show you one more. State a name. Here we're getting the column state a name. And I believe I can also create a little vector here of county a name. Cool. All right. So, oh, sorry, you can't see that at all. Let me show you what I just did here. So, different ways to get into our data. df dollar sign and a column name gives us that whole column. df and then some numbers. The first number is the row, the second number is the column. So 1, 1 gives us row 1, column 1. You got to make sure you get the comma in there or you're going to get some error codes. Get those error codes on your own computer. I'll do just 1. So if I do df1, in that case it's giving me the first column, which isn't what I'm expecting. So scroll way back up here. I don't have enough memory in there. All right, so that's fine. So df dollar and then a column name gives you that whole column. Number comma number tells you what row and what column. We can do a span of columns. We can do a span of rows. We can do both, so we can get the first 3 rows and the first 3 columns. Or we can refer to these by the column name, or we can refer to multiple column names using a vector in the C function. So we do that. Looks like it's going to work fine. So let's go ahead and say for, let me get myself out of the way so you can see me code here. Blank and then a comma means we're going to take all the rows. And then the columns we're going to deal with will be state a name and county a name. And the row we put that, the order we put that in shouldn't matter. And then back to help to see what we're doing. We've got our data is df, our indices is these columns, and then our function, let's do mean. And let's see if we get something that makes sense. So if we run this, it's going to take a while because it's a big data frame it's looking at. It's going to spit out a bunch of stuff, and notice we're getting all these NAs. NA means, well, actually, let's see specifically what NA means. Not available, or missing value. In my head, it's not applicable, but it means the same thing, right? If you get an NA value, it's not applicable to, say, something like adding things up. So what's 1 plus 2 is 3. What's 1 plus 2 plus NA? Well, it's just NA, right? It's not a number. So what we want to do is we want to get the mean, but we want to reject any NA values. So NARM is what's going to do the trick for us there. So let's specify here na.rm equals true. Let's see if that works better. Argument x is not missing, or sorry, is missing. So it's not happy with what we've got here. Let's try x equals dot and see if that works. Object dot not found. All right, like I said in class this week, sometimes dot is like a placeholder. In this case, it's not going to do the trick for us. How will I do this? I'm going to let's do like this. This is a slightly hacky way to get this done, but it'll do the trick. There are nicer ways to do this, but I'm rusty and I don't know them off the top of my head. So I'm not going to make you watch me figure out how to make this look better. I'm just going to make it work. So I've created NA mean. Let's go ahead and load that into our workspace. So if we do NA mean, which is showing up as a function, that's good. If I take NA mean of 1 to 3, I should get 2 as the average value back. That's good. How about if I do 1 to 3 and NA? I get 2 back. Good. Now, if I did that with regular mean, I'd get an NA back. 1 plus 2 plus 3 plus not available divided by 4 gives you not available. But if we just throw away that NA using this, then we're just doing 1 plus 2 plus 3 divided by 3, and we're getting 2 back. Cool. So that should do the trick for us. So let's replace mean with NA mean, and let's see if it works now. Oh, whoops. Without anything in it. Now let's see if it works. Okay, we are still getting NAs. Ugh, what is going on? Are these just counties where no one's going to? It's possible. All right, I'm going to let that scroll through and we'll see if maybe some numbers come up, but I'm going to go ahead and stop this. All right, so this isn't doing what I want. Let's throw this into an item we'll call X, just sort of a temporary placeholder. And then if I look at X, let's use view X, capital V on view, and 51 entries, 1,800 columns. So this is, man, this is not what I want. All right. You know what? Most of what we do in R is we run into problems and we try and solve them. So let's try and solve this. We'll go back to help and see if we get any hints here. Not NA, by. Okay. So when we're looking for by, simplify equals true. That seems fine. Logical CT apply. We might have to dig into T apply and figure it out that way. Blah, 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 blah. Other objects are also coerced to a data frame. Okay, data frame is split by row into data frames subsetted by the values of one or more factors. It should be forcing these things to be factors. Here's what I'm going to do. I'm going to, rather than do it this way, I'm going to make just a df unique location. And this will be df state a name. Actually, you know what? Paste df state a name, df county a name. So now when I look at df, we should have Alabama, Autauga County. Right? And that's just a new variable. Let's see if this gets a little bit better. When we run this through here, we'll call this, actually let's even see what happens if I just do unique location. See if I get an error. Okay. Not found. df dollar unique location. So far so good. We're getting some warnings. We're getting something very similar to what we had. But we're at least getting 3,100 things, which is in line with the population we've got. Okay. So far so good. I guess we got rid of 3 rows where there were NA values. Split this. For the default method, an object with dimensions is coerced to a data frame and the data frame method applied. Other objects are also coerced to a data frame. So, ooh, I think I know what it is. I think what I'm actually trying to do here is I'm trying to get the mean of in percent and then out percent. And hey, that looks a lot better. All right, cool. Nice. Let's see what kind of data type this is. What is X? It's a by. Huh. Interesting. So X is some value. It's a, I think it's a one-dimensional matrix. So if I were to say as dot vector X, then it spits out as that. And if I ask what is that, it's a numeric vector. Okay, that's fine. So by default, it spits out this slightly weird looking thing. So we will force that to be a vector for our purposes. So let's call this, instead of X, let's call this, what am I doing? I'm looking for the average in, let's call this mean in by county. That's fine, we'll leave it as mean in. Let's change in to out. And in both cases, let's make this as dot vector. So we've got these things. Now there's a slight weirdness here. Which is we've got these 3,140 items and we kind of would like to match them up with the values in POP. This is a lot easier in tidyverse, but if you don't have access to tidyverse, which right now I don't, then we'll try and make do with what we can. Oops, there we go. That should be mean in, mean out. I'm just going to focus on these two, and then if I change these, actually, you know what? I don't want to make a NA everything. So let's just see what happens if I get rid of this and use the normal mean. Mean in, looks good. Mean out, looks good. Cool. Although it's still 3,140 items. This is kind of odd. Huh. All right. Well, whatever. I'm not gonna sweat it just yet. Actually, let's go ahead and figure out what the difference is. So let's look at pop. What I'm going to do is I'm just going to sort by population, scroll way down. Okay, I'm not seeing any NAs. That's good. I'm not seeing any zeros. That would throw up an NA if we were dividing stuff by 0. Everything seems okay. Can I search for an NA? Search for a literal NA. Filter, that's not what I want. Okay, well, whatever. Let's close these. I'm pretty close. I've at least got the mean. And I don't need this. That's nice. All right, well, let's start here and change mean to median. And then let's change mean to min. And then to max. And SD for standard deviation. These function names are pretty descriptive. Mean calculates the mean of the inputs, min finds the minimum value of the inputs, max finds the maximum value, and SD finds the standard deviation. So let's go ahead and just, well, let's Control-Shift-S. Run the whole thing and see what we get down here at the end of this. We should, I think, get an error for here. That's fine. This stuff should all clear out in a minute. Hopefully less than a minute. Cool. All right, so we got all these values. The min out, predictably 0. Our max out is not 0. That's good. Means, medians, these all look like normal looking values. They're all 3,140 items. If we could find which 4 items aren't in here, that would be great. But these are just the numbers themselves. So, can we figure out what numbers are missing? Well, I don't have a good answer right now, except install tidyverse, because it makes it easier. In any case, we've got the calculations done. We've done the summary stats, and we've done it by county, by unique county, because there are some county names that repeat. There is a Suffolk County in Massachusetts. There is a Kings County in New York and California. And then there's a few county names that are like all over the place. But we've at least done the calculations by group. So what have we seen so far? We've imported data, good. We've combined that data, excellent. We've calculated some values and created new variables within our data, awesome. We made a useful temporary value. We don't really need this, but it just makes it a little bit easier to do our by application in this case. Cool. So far, so good. Now, I wonder if I couldn't use names to get this closer. So let's try something. Names. Oops. I'll ask the help. So any object can have a name. So a data frame is going to have column names. You usually don't want to do row names. It's not sort of the normal way of doing things. The row names, really the column names too, but we don't want to be trying to identify stuff by those parts of what we're looking at. It might not make sense until you've been doing this for a while. But the functionality exists, so we're gonna try and use this. So I think we want row names, vectors, yada, 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 attributes, blah, 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 for a one-dimensional array, dim names. Oh, maybe that's what I wanted. Maybe I don't want this as vector thing. Let's try something real quick. Let's run this without the as vector. If we look at the head of mean in, we're getting the actual counties. Good. So, without the vector, we're getting the names of these unique locations attached, which is slightly weird, but what that means, I'll get to this in a sec. What this means is we can, let's go row names df are going to take the value of df $unique location. So it's going to take a sec, but then if we look at the head of df, it's still naming them one to so on. Error. Okay. Duplicate row names are not allowed, and that's a good thing. Unique location, Alabama, Blount County. There shouldn't be duplicates in mean name, but there will be duplicates here. Okay. The trouble here is we've got many versions of different county relationships with, say, Bibb County in Alabama. So in Bibb County, Alabama, people might be moving in or out from many other counties, 3,000 other counties. So we're going to have 3,000 copies of that unique location value within this column. We can't name things with repeated names because a name should be a unique identifier. Okay, so maybe what we're going to have to do in this case is, well, let me start by getting rid of all this as vector stuff. That didn't work. Yeah. That took too long, but whatever. So now when we run this, these things will have names. Now I think we should be able to, I wonder if we can take each of these and create a data frame. I think that's what we want to do. So we get this thing, which is going to be a vector with named items. We want to take those names and stick them on as an extra column. So if we say mean in $unique location, I want to spell this the exact same way as on line 12. I'm sorry, let me clear my highlights. I want to spell this the same way as here so that we'll be able to merge it after. So if I take my unique location for mean in, that is going to be names of mean in. Maybe. What do we get? Nope. Okay. So list vector. Okay, slightly weird. Let's do like this. Let's say mean in is a data.frame where mean in equals mean in and unique location equals names of mean in. Let me see if this works before I explain it to you. So calculate that mean, set that up. Let's look at if mean in worked. Let's look at just the first 6 rows, not all of it. All right. So hopefully you can kind of see a little bit of what I was talking about with naming rows. So our rows are named, which is not really what we want to do, but that's fine. We'll clear that out in a sec. We've got a unique location, which is the same as that row name. We'll get rid of these row names when we merge it back into df. But we've got our mean in values. This looks good. Let's just see what happens when we get merge mean in and df. And let's look at just the first 6 rows. Looks good. It renamed, so we don't have to worry about dropping the names. I was going to add an extra line of code where we did that, but we're not going to worry about that. We could, if we wanted to, get a little bit crazy and create some functions to do this and then apply over those functions, but we're not going to worry about that just yet. Certainly not since we've been going for 36 minutes. So, what we've got here is we've got, okay, those are the in percentages. Have we got the mean in? That should be here, and notice it's the same for this same county, the same unique location, because it's the average across all of those. So if we look at their in percentage, we'll see different values, but if we add up all those different values for this particular county, it should average to that. All right, so I'm going to take this, whoops, I'm going to put this down here, and what do we got? Paste that 9 times. So let's change this to mean to median, mean to min, mean to max, and mean to standard deviation. And then I can take these and change in to out, and that should, yeah, that should do what I need it to do. So now let's merge this all together. Actually, I'm going to keep that last row, that last line, just to remind myself. So let's call this out df. Is going to be a merge of what? It's a merge of df and mean in, which we can then merge with median in, which we can then merge with a bunch of stuff, min, max, SD, right, merge with mean out, and then change in to out for these, get rid of that last pipe. Okay, so I'm going to see if this works, and it might take some time. And while that's compiling, while that's figuring itself out, let me explain what we've done. So, cleared everything out, we load in our data, we merge our data, we calculate percentages, we add this unique location just to make it a little bit easier. We can delete that after. That unique location that combines state and county name, just to avoid any issues of duplicate county names. And then we're calculating the mean by unique location, by county state, for each of these different things. For in percentage, for out percentage, using the function mean, then using the function median, then min, then max, then standard deviation. Then for each of those, I take that calculated figure, which as we saw before had named rows, which turns out to be convenient for us. We take, say, mean in, and we're going to put it into a data frame where we're going to create a column that's also named mean in. It doesn't have to be named mean in, but I'm just going to do that here. So these two mean ins mean something kind of different. Just a little bit confusing sometimes. On the one hand, it looks redundant. Some coding languages would set this up so that you don't need to put both. You just say mean in and it would figure things out. In this case, we're just specifying we get a data frame with a column named mean in, who takes its values from this other object we created before called mean in. And we're going to create another column called unique location, which takes its values from the names of the thing we created called mean in, and creates something like we saw before. And then we do that for all these different summary stats, and then we merge them all together into outdf, which, as we can see, takes some time, even on your own computer. This is an older computer, but it's not that old. And then what we should be able to do is put outdf into a whole new thing. All right, let's give it just a sec to see if this finishes running. When something takes this long to run, there's two possibilities. Well, there's many possibilities, but one possibility is that it's just a big job. Or maybe I've got other stuff running on my computer that's slowing things down, like, for example, running recording software. So it could just be that it's slow, and that's fine. It could be that it's caught in like an infinite loop or something, or there's some error. So when this is finished running, it's hopefully going to spit out nothing, and I'm going to be able to access this thing and have the work done. Might spit out an error code, but I'm not going to make you guys wait and sit around for that. What we have seen in this video is the base R way to do it, although we haven't totally checked our work yet. We kind of had to do a little bit of hacky stuff to get this to work, and you can see this takes a lot more lines of code than the tidyverse way. There's a lot more places here where you can make a typo, where you can make a silly mistake, and when you do that, you're a lot more likely to lose it and then copy it. Right? So if I had a mistake in mean in, and then I copied and changed it to mean out, but I didn't fix that mistake, now I've got to fix two mistakes. Right? It's the same mistake in two places, but it's still more work. But hopefully it works. Hopefully we got it. We'll see. It's still running, but whatever. I will upload this, and as usual, if you got questions, let me know in the usual places, and I'll talk to you in the future.